Good day, everybody. Randy Franklin Smith here, and we've got an awesome topic today. Just lots of fun, and this is all about looking at threat hunting and being able to do threat hunting no matter what your environment, no matter what your resources. Pretty much all of the threat hunts that we show you today are scalable, is the best way to put it, meaning that you should be able to do them whether you are a full-time threat hunter or maybe you only have a little bit of time to apply to this each week. And we'll try to highlight how that's possible with each of these as we go along. Now, today's awesome Real Training for Free is made possible by Logarithm, and I've got a really interesting colleague with me here. Q, thanks for joining us, and please, like I said before, jump in and share your thoughts and experience and insights as we go through our stuff today.
Sounds great. Thank you much, Randy.
And we're going to jump over to Q once in a while to just show us some examples of how you can really do this in a SIM, because some of these are kind of sophisticated, and you might be wondering, could you even do this in a SIM? And so we're going to show you some live examples of them. So I actually ended up adding one, so we went from 7 to 8, but here's a quick rundown of what we're going to talk about. We're going to say, look, you can go out hunting for suspicious software. You can go out hunting for behavior changes, scripting abuse, following up on AV. This is an interesting one, especially that came from Q. Lateral movement, both from the point of view of endpoint and user account. We'll talk about recognizing when bad guys try to gain persistence for their malware, DNS abuse, and then finally bait the bad guys. So these are just tons of fun. Please use the question window to share any and all feedback along with your questions. And let's get started with our first one just as soon as we talk about what it takes as a minimum to do threat hunting. This is all about correlating log messages to a large degree. You want to talk about this one, Q, because you really put this together.
Yeah, most certainly. So one thing that I try to focus on when I talk to clients or things of that nature when it comes to threat hunting is being able to see the data that you're interested in. And the first part of being able to see the data you're interested in is obviously collecting data from the right sources and making sure that data is adequately parsed, effectively within your SIM, within your tools that you're using. So when it comes to log sources, we all want to gather logs from every aspect or crevice of our network. So I kind of made this little chart just to kind of give you an idea of what it is that we're looking for. Your network devices that you have in your environment, your firewalls, routers, switches, things of these natures, your endpoint systems, your Linux systems, your Windows systems that you have running in an environment, and the log sources that they generate themselves. If you're on a Linux system, your var log messages, audit logs, host logs. If you have key logging on or kind of a application, other specific applications like Apache or Tomcat or whatever you have in that environment. Then your Windows logs, obviously Randy is, the God Supreme, Omega Supreme of Windows event logs. So obviously your system applications, security logs, and other important things, your sysmon logs, kind of your endpoint detection sort of systems, things like that. And then you want to move into your security systems. Do you have your EDR logs, email logs coming in, vulnerability scanners, are they logging properly? Your AV systems that we'll talk about here in a little bit. And then naturally your other internal systems, your file servers, emails, your authentication systems, your Radius servers, Kerberos logs, AD systems, your VPN systems, as far as your network security systems, proxy logs, emails. I mean, so there's a lot that goes into it. So I always find it to be a little bit helpful to have a little checklist here. Do I have this? Do I not have this? Am I, follow your compliance sort of framework? But when we're talking threat hunting, it's just so critical to have, the proper logs feeding your information. Otherwise, you're going to be left, with a visibility gap.
Yep, and a blind spot. So to do threat hunting, we need our logs, and the first thing that we can hunt is recognizing suspicious software. So let's talk about this particular kind of hunt. You can go about it, and I've tried to break this down into a more or less standard chart for each one of these hunts. First of all, saying what's the basis for it. So we're saying we can hunt for malicious software either going with the process name or with its hash. Now, there are significant differences and implications with both of these. The advantage of going with the process name is that it's just far easier for several reasons. Number one, for the source of the data, we can just use the good old Windows security log that's already there. There's nothing to install the way there is if we're going to use sysmon. The downside is process names can be spoofed. So bad guys can do things like name their malicious exe or DLL as a name it after something that is legit. They could name it Notepad. They could even possibly replace Notepad.exe with their own exe, and so then they're going to be masquerading, and that would defeat that basis that we're using. But I don't want you to immediately discount it. And I think, by the way, Q, you might run into this. There is a real danger with security professionals we can always think of the way around a control or the way around some kind of monitoring, and then sometimes the knee-jerk reaction is to cast it aside, saying, well, there's a way around that, so there's no point in enforcing or enabling or doing that monitoring or that control. But go ahead.
Exactly. I think you're 100% correct. And the clients that I talk with or I speak to, specifically when we start looking at, like, say, PowerShell logging or things of that nature, we have some clients that are like, well, we use PowerShell logging in every instance, of our IT infrastructure, or that's how we monitor a lot of systems. So I don't want to trigger on, known uses of PowerShell, because we use it internally, and it's going to cause, it's just going to be alarm fatigue, but and then they end up just throwing all of the PowerShell logging out the window, and it's like, no, but that's a very high common, attack vector for living off the land for attackers. So it's like this balance, it's like, can you still detect the thing that you're looking for, but then, as you're saying, use hash values. I mean, you might have a poisoned, PowerShell that shows up on a system, and you still might want to be able to detect that.
Yeah, so that's the other route you could go, is to monitor for new hashes. And that is far higher integrity than monitoring for process names, because that's the other thing. We could modify the legit notepad.exe and then insert our own code that gets run whenever Notepad starts. But the thing with hashes is that hash will change one bit out of an exe, and theoretically or generally or probability-wise enough to count on it as certain, the hash will change. But the problem is it's really hard to do hash monitoring. And so before I get into all those problems, what I find companies doing is saying, well, there's no point in monitoring process names because you can spoof those, and hashes is too hard, so we don't do anything. Okay, well, if you can't do hash monitoring, then do process monitoring, because guess what? Most of the bad guys, most of the software that I run into out there is still using some process name. They just try to disguise it and make it look legit, and we'll talk about some examples of that. I think it's, if it's not here, it's as we go along, but they would name it service host, but just rename, rearrange service to where it's like srvc host.exe or something like that. Well, process name tracking is going to catch that.
Exactly, and and SIMs kind of are in kind of a unique position. I mean, you don't really want a SIM to be taking the place of an AV because AV has other functions that it does really well on a granular level. But SIM is really good at tracking lists of values. So doing things like you just said, if you see SVC host, but then you see a misnaming of it, so SVV host or SCV host or SVC host, I mean, you can change those things, and the human eye might miss it just ever so slightly, but a machine is really fast at detecting those changes and then alerting you on them.
And, well, but here's the other thing too, Q, is if we're just keeping a list of known process names and the bad guys try to slide one past us like a misspelled service host.exe, it's going to pop up on the list. And so you should be thinking, oh, why is service host on the list? We know that, well, it must not be exactly service host. Let me look at it. Oh, that's not service host. That is SRVC, host.exe too, so it can actually be very, very effective because hash monitoring is difficult. First of all, we've got to install, configure, and maintain sysmon or be using an EDR solution. And then hashes are far more complex to monitor also because every time a file gets every time a file gets patched, you're going to get a new hash. And, Windows gets updated so frequently, and all the apps on Windows get updated so frequently that creates quite a burden in keeping track of your whitelist. It's not a matter of just downloading the National Software Register library. And I don't know. You probably know the thing I'm talking about.
Well, exactly. Like NIST has a golden value of all Windows, legitimate hashes. You can use that. But see, this is where I kind of default towards, I mean, I work for a SIM vendor, and I'm pretty partial to how SIMs function. But I mean, I have to rely upon those tools and those security tools that do this, very effectively, and those would be your AV systems. I mean, the way AV is working with the the cloud and trending sort of aspects. I mean, I just throw the cloud out there, but the trending aspects of peer set evaluation groups and using that kind of the new lingo of machine learning and all that stuff. But I mean, they're saying that we see these hashes or we see these values trending as as more suspicious than others. When you have these new updates and stuff, I mean, you as a SIM, we kind of have to rely on them because this is what they do for a living. This is their focus, and then we can use hopefully their hashes, their alerts, their logging that they give, and they're alarming to say, hey, they're giving us an alarm. Let's flag on that, and we see also some other sort of activity. So we're trying to do that kind of aspect, but the AVs do it, and they do it really well. So we should probably lean on them.
Yeah, and there's some interesting ways that we can leverage it in a way you might not have thought about, some of you out there. And I'm really interested in your feedback on that. And before I go to that slide, one other complexity here to be aware of if you're trying to monitor for hashes, and that is that you be aware that .NET compiles hundreds of DLLs on every system out there, optimizing them for the local system, for the particular CPU that you have on that system. And so that's going to generate a lot of hashes that you may not have seen anywhere before. By the way, also before I leave, if you're going to do process name tracking, then you probably just want to use 4688 from the security log. It gives you the full process name and even the full command line. And all you've got to do is turn on audit process tracking. But if you want to track hashes, and unless you've already got an EDR agent out there that's giving you this feed, then you would install sysmon. I've done a bunch of webinars on sysmon along with logarithm. But the three events would be process creation, driver loaded, and image loaded. Those three different events will give you the hash of every exe and DLL that is executed on your system or loaded for potential execution. So let's drill into these a little more though. With process name, here's what we'd want to do. We'd first of all want to create an initial baseline of all EXEs seen in whatever our available history is. If we have a year of log data, then basically Q, I know you can't necessarily run this exact SQL command against logarithm or another sim, but in essence, what I would like to do is do a distinct query, select distinct on process name from my events table where event ID equals 4688. And that would give me, searching all my history, a nice deduplicated list of all process names,
Exactly. So logarithm has a kind of a way to do this. I mean, within an AIE rule, we call it a whitelisting rule block. And what we would do is we would specify, I guess, origin, event ID 4688, and then we would group by the process name, and we'd want to have that unique process name. And then what would happen is the AIE rule would say, I'm just recording every single 4688 that I have, and then if I see it and it's not part of my list already, I'm just going to add it to the list. So we would let that learn for a period of time, or we could populate it with a list that we already know or we would already like to have. And then after it's learned for a bit or you've taught it what it is that you would like, you can then hold that as a whitelisted value across other systems in your environment that may have that same sort of system set or something of that nature. And then if something were to be outside of that list that is good, your golden list, say, it would then fire an alarm or let you know. But then it would also skip past those that are already on the list.
Yeah, exactly. And I would want, and that's basically what I've got in the drop downs here. We're saying once we got that baseline, then compare the process name from new 4688s against the baseline. And here I've done it again. I just like to think in terms of SQL. So I'm basically saying if, take that event, take the process name from this event and go look throughout my history. And if it comes up as 0, meaning I've never seen this process name before, then, wow, this is new. It's new to the baseline. So there's two things I'd want to do. I'd want to add it to the baseline, and I'd want to get it in front of probably an analyst to evaluate. And, this would not be a high fatigue situation unless you have some process out there that is constantly compiling new, unique exe names and running them. Unless you've got something very weird like that, Q, then this is not a high fatigue thing to watch.
Yeah, and there's also another kind of piece that goes into, and you're exactly correct. When you have that baseline and then you have these one-offs that are occurring, it gives the analyst a little bit more time to say, is this legitimate? They can drill down into it, do a little bit of, Google foo and see if it's actually suspicious or not. And then if it is, I mean, there's a lot of different processes across a lot of different SIMs, and it's a term that's coming around a lot. It's called SOAR, or systematic operations automation. So it allows you to automate, more I guess templates how you want to work on something. Allows you to automate a process. Say in this example, if you found an exe that is new, you would want to add that to the list or add that to the known, good baseline if it was part of that category. Then you would actually use the SOAR operations, which would automatically add it to the list. There's a lot of different tools to use that with, Swimlane and Domesto and Phantom, and there's a lot of different ones that are out there. Logarithm uses smart responses. And you can automate that process of adding it to the list or further doing actions in the future, but have to use it.
Yeah, no, I mean, you could Google the process name, like you said. You could also go get that actual file from the system where it executed, and then submit that file up to Virustotal, and let's see what Virustotal comes back to. Now, folks, pay attention here on this one thing. When I'm submitting it to Virustotal, I'm not submitting it to find out if Virustotal calls it malicious or not, because I regard that as the job of AV. I mean, if our AV hasn't flagged it as malicious, there's a chance Virustotal, looking at all the other virus engines, may. But I'm more interested, and I think what really makes this worthwhile is submitting it to Virustotal to find out the following information. okay, Virustotal comes back and says it's neutral rating, but Virustotal says or maybe Virustotal comes back and says we have never seen this exe before. Okay, I'm going to be interested in that. Unless this is just a patched version of Notepad and we're the first ones to submit it, which chances are going to be against that. More often, Virustotal is going to come back and say, yeah, we've seen this exe. It's neutral rating, but look at how long ago Virustotal started seeing this. Has Virustotal seen this exe for months and even years, and it still has a neutral rating? Well, chances are it's safe. Whereas if Virustotal says, man, we just started seeing this like a few days ago or a week ago, or we've never seen it, that pushes up its suspiciousness in my eye. Do you see why, Q?
Oh, exactly, 100%. Yeah, Virustotal is being fed by so many different sources. It's a good bellwether to see what's happening in your environment.
Yes. Let's see here, because this could be targeted malware, and that's the thing I'm really interested in catching, is targeted, because that is the most dangerous stuff out there, stuff that was compiled for you, and don't kid yourself that you're not important enough to be targeted. But the other thing is malware and threat intel lists pretty much select against targeted stuff. You know what I'm saying? Because what's going to show up on a threat intel list? What's going to show up in AV? Stuff that is being used widely enough to be seen and observed and make it into the list. You know what I'm saying? So,
oh, certainly.
This is really cool use of information. A sandbox. It's also possible to go and submit this thing to a sandbox and see what it does. The other thing you can do when you submit something to Virustotal is it'll show you about the innards of the file, like what are the imports of this file. And by imports, that means what DLLs does this file use, call out to, and what functions on those DLLs. That tells you a good bit about the behavior of the program. And that can give you insight too. But the thing of it is we're probably not going to have time to do this manually, Virustotal and Google it and submit it to a sandbox. But again, that's where security automation orchestration comes in. And I know that's something you guys are really trying to lead on.
Yeah, exactly. We're trying to get that context to come back into your environment as fast as we can, and we're going to use security automation to make that a reality.
So Aaron has an interesting point here. As devil's advocate, he says if you're uploading targeted malware to Virustotal, that can tip the attacker off to the fact that their malware has been discovered in the environment to which it was deployed. So you have to ask yourself there, Aaron, are we trying to hide the fact that we're on to an attacker? I'm not sure that we are. I'm trying to detect that I've been compromised, and if the attacker learns that I know about that, I'm not sure that that's really a downside. But hey, for some of you out there, you may be.
Yeah, no, I mean it's a good point to realize, and that's why when we always say when you're going to Virustotal first, you're just looking up the hash. You're not actually submitting it from the very beginning, because that could. I mean, if you are worried about being targeted in that aspect, and to be honest, I mean, relatively very few companies are actually really targeted in that aspect, but it is something to always be aware of and to know what your actions are doing, your side of your consequence of your actions.
Yeah. And so Aaron says, ideally we'd all have a sandbox that we could detonate it in, but not everybody does. And so that's the point of all the different options we're throwing your way is most of you will not be able to do all of this, but most of you will be able to do some of this for each one of these threat hunts. And hunting is not a, what would the term be? Hunting is not an all or nothing proposition. I guess that's the point to make. Let's see here. Tyson says, where are you running this query from or against? So Tyson, these and everybody else, these SQL commands are just conceptual. I don't know which SIMs you have, and there's way too many SIMs, and I don't know the query language for every one of them. So I like to express things in, the widely recognized SQL language just for conceptual queries that I'd be running. Okay. Now, could we go beyond a global baseline? Could we baseline individual endpoints and users so that we're still on process name here, but could we keep track of what normally runs on each computer? Could we keep track of what are the program names that each user is known to run? Okay, so there are ways to do this, but just be aware, if you go down this road, one of the big things that you need to do is know how long you've been observing a given user or a given computer, and even program names, because we could leave out program names. There's not that many new program names, but we could, for endpoints and users queue, ideally, I would want my system to say, hey, this is the first time we've seen this user run this program, or this endpoint run this program. But by the way, this endpoint's been around long enough for us to have a baseline for it, and this user's been, if this user's just been hired, then don't bug me with every new program he runs until it's, until we've observed 30 days or a week of his activity. You know what I'm saying?
Yeah, you're exactly correct. Your time is a big factor in that. And then, subsequent auditing of that list to make sure that you're not missing anything at what are those processes that you have witnessed them using, and then you have to do a little bit of due diligence beforehand to make sure all those processes are actually right. Otherwise, you could be, missing one that's just kind of stuck in there, that snuck in.
Hey, Aaron, Paul has an interesting comment here. I hadn't thought of this, Paul. Thank you for sharing it. To search Virustotal without tipping off an attacker, don't upload the binary. Instead, just search for the hash in Virustotal. That's probably pretty cool. It probably would work. Thank you. Aaron says, nice tactic.
Yeah, no, it's a really good aspect. You have to be careful. There was some AV vendors that came up, and they were very cheap and in a very simple. But basically, all they were doing was taking every single AV sample you had in your environment, and they would just upload it to Virustotal and see if it was seen or not in that. And so you have to be careful with your AV vendors. Make sure that they themselves are also not just automatically uploading things to Virustotal as well. I mean, it's not really common for your better AV systems, but be aware of that if you're using a free one. Good point.
Let's see here. Okay, let's move on and talk about hashes. This is similar investigation, similar process to follow. The differences, there's going to be many more hashes to investigate than program names. Basically, every iteration of a given EXE or DLL, every single time it's patched, is going to be a new hash. So it's critical to maintain a whitelist of known good software that has to be very, very, very up to date. Simply scanning a golden image is insufficient unless you're not patching your systems. But if you're not patching your systems, that's a whole other problem. So this whitelist needs to be updated before a hash, before a patch hits production. I've done a lot of thinking on how to do this, and I came up with two ideas. Number one, can you scan your patch testing systems? So the systems that get patches early and you do testing on, could you maintain your whitelist from those systems? Treat them as an avant-garde system and assume anything showing up on them is whitelisted, and safe. There are commercially available whitelists, but when I have tested, the ones that I've tested, and when I tested them, they were not nearly up to date enough. Like we said, you could look it up against Virustotal. The other thing, I'm encouraging patch management companies to include a new threat intel list of known good software, because as soon as a patch comes out, they're going to be downloading it and packaging it up. And they have the perfect place in the pipeline to capture this and then publish a constantly updated whitelist, but that's just an idea. Now, if you tackle these challenges, the cool thing is you'll know within minutes whenever a new binary file executes on your environment, whether exe or DLL. But so that's cool, that's great. Michael says, is there a way to make Windows Event 4688 include a file hash? No, absolutely not. That's why we're saying you got to install sysmon. All right, so if you do all this, then you're going to know when a new exe or DLL runs. But you're not going to know two things related to this. Number one, buffer overflows and related non-exe binary code. So the bad guys have come up with a whole bunch of ways to get binary code to run without ever loading an exe or DLL or even putting it into a file. It doesn't mean we shouldn't be doing what we were just talking about, but I just always want you to be aware of coverage gaps. But the other thing is scripting abuse. Bad guys don't always use EXEs and DLLs, and especially the ones that are trying to live off the land and go fileless, like stay off the file system, they're using scripts more and more. So let's segue and talk about scripts in just 1 second. This is the one I inserted just as I was getting ready to move this thing and release it to press, and that is behavior change. So if this feels inserted, it is, because as I was working, I'm like, I can't do this webinar without inserting this one. And this is similar to process name, but we're adding in parent process. So what we'd be doing then is searching for new combinations of a given process and then the parent process that executed it. So in other words, if you see something like if you see something like Microsoft Word running RDP exe, that would be really weird, right? Maybe there's nothing malicious about Microsoft Word, and maybe your users use remote desktop. But if you see Word starting remote desktop, now that is weird, right? And so you can do that with event ID 4688, or you can use sysmon process creation events for that. And I think we already talked about username and process name. Yeah, we already talked about that on the previous one.
Yeah, the parent process name and process name combinations are very key. I mean, especially when it comes to things like Mimikatz or stealing credentials or something of that nature. I mean, you might have Word that is all of a sudden executing app command if you're on a Windows or you're on a Windows server, or if you're on a local desktop, 10 or something of that nature, Windows 10. You might see LSAS running, but if it's running from something else other than Windows System 32 or something of that nature, there's little keys in there. It's like, why would command .exe ever need to execute explorer.exe? Where does PowerShell ever need to make an outbound connection? Things of that nature, and you want to be able to see those parent processes and then what processes they're subsequently giving off.
Yeah, and again, this is not a high fatigue alert, but it's high value. All right, now I'm ready to talk about scripting abuse. So bad guys trying to evade our last threat hunt and trying to evade application whitelisting, trying to be stealthy, are going to resort to scripting languages already available on your endpoint, and that's primarily PowerShell and the Windows scripting host. So what can we do? Well, the simplest thing that we can do, and it may not work for everybody, but for some of you it will, is simply monitor for the execution of a scripting engine. So that means we're looking for where it says process name right here in the subsource. We're either watching event ID 4688 from the security log, or we're watching sysmon event ID 1, and we're just looking at the process name. We're watching for C script, W script, or PowerShell. Those are the exe names of the Windows scripting host and, of course, PowerShell. Now, a bunch of you out there are going to say, well, we use scripting all the time. That won't work for us. Fair enough. Then, is that true of all of your endpoints? Maybe on your servers you use a lot, but maybe not on your workstations. Or why don't we add another dimension to this and track the user account? So maybe scripts run all the time on your various workstations and servers, but they're being run by the system account or some other batch account that you've set up for that purpose. Are they commonly executed by end users? And do you have so then do you have the problem of, well, our admins run scripts but not our end users? Well, does your naming convention allow you to distinguish between those accounts? See, for just about everybody, there's going to be some way that you can detect when scripts are being used, scripting engines used in a way that they are not normally used. But let's look at some other possibilities. The bad guys, when they use PowerShell, are commonly not using a script file name, and instead they are just dumping the whole script onto the command line. And then to help obfuscate that, they're encoding it. So it's just a bunch of gobbledygook. Well, the thing to look for in that case is the encoded command parameter. So we're looking for a 4688 or an event ID 1 with PowerShell.exe and encoded command. That should be a tip-off right there, because what are the legitimate reasons to run an encoded command queue? Not that many, right?
There are some legitimate processes. Like we have within Logarithm, we have a system that does actually use PowerShell encoded commands as part of its normal operation, and you'll quickly find that.
So let's whitelist those.
Doing it. Yeah, exactly. Yeah, whitelist those origin hosts. Exactly.
Yeah, learn your environment and whitelist it. Okay, another one is parent process, though. This is going to be a little more difficult for bad guys to cover up, right? And this can be the thing that really cracks it open, makes it practical in your environment. Yeah, we know scheduled task runs PowerShell, but again, why is Word running PowerShell? It makes no sense. Why is Outlook or Internet Explorer running PowerShell? And then script file names. Okay, so scripts are widely used. So can you just look at the script name on the command line and whitelist your known scripts? Here's another thing. Naming conventions so oftentimes can help you separate the noise, the signal from the noise. So if you say, okay, we use PowerShell, why not start all of your PowerShell script file names or scripting host, Windows scripting host file names with some kind of prefix, and then alert when you see a script running without that. Now, the first thing someone's going to say, Q, is, yeah, well, then the bad guys could use that against me. Q, how many bad guys are going to know about that? You know, it's
yeah.
If this is what it takes for you to do monitoring of PowerShell scripts, then do it and live with that risk, you know?
Right, exactly. You know, I think the PowerShell is an interesting one, as I think we'll get into here with a demo and everything like that, is you know, PowerShell is kind of difficult to parse. It's a very large log. So I think a lot of bad guys are kind of expecting people not to really be parsing it, or not to really be looking at it, you know, very heavily. But there's, you know, PowerShell, especially after version 4, has so many aspects in which you can track logging and, you know, different little capabilities inside of it, that it's a wealth of information, especially if you are fearful or you have a risk or a slight threat of PowerShell.
Yeah, and you can also, for what that's worth, you know, looking at scripting engine behavior with the Windows scripting host, that's pretty difficult because there is no auditing of what the scripting host is doing other than just watching what it's doing at the Windows level. But the cool thing with PowerShell is PowerShell also has audit logs that will tell you every single code block and every single PowerShell command that is executed. And so you could also baseline that of what's normal. Like, okay, so we use PowerShell, but we're using PowerShell for a fairly limited set of functionality. Now, you want to show us how could somebody actually do some of this in a sim, Q? I'm going to make you the presenter.
All right. All right, can you see the screen all right?
Yeah, yeah.
All right, fantastic. So this is a dashboard that I created, and it's specifically called, it specifically targets Sysmon and PowerShell. So essentially, Logarithm parses out specific logs and then gives them in specific, metadata fields. And what I did is I took all those metadata fields and I essentially tried to visualize it as much as possible. So the first half that you have up here is Sysmon, and then the bottom half you have down here is PowerShell. And I'm going to get into a couple of these things. And when you break things out into interesting little unique pieces, you can start, understanding kind of what your environment has. Just a little bit to how PowerShell or a Logarithm works within this. Essentially what I did is I took my source name and I said anything with Sysmon, be that either XML or non-XML, I want to be able to parse just those events. And then what I did is I said, I'm gonna go in here and I just want to know just the vendor message IDs that have on that. So now I can see everything that is PowerShell 1 or as VMID 1, right? So that's just a creation, a system creation. You can also go in here and say MPE rule name, and that kind of gives you a neat little insight. And you can say, oh, how many file creates did I have? Well, within my test environment, I had 590 file creates. So you can see there's quite a bit in there. But I can also see that there's create keys, there's registry value changes, image loads, all those different aspects. And it kind of gives you a way to just break down what your environment is doing relatively quickly. But then you can kind of do some interesting things with that. So if I know that registry modification, like a registry value set is like a 13, and I know that registry event creation is a 12, then how about this? I can say process names. So I want to know exactly the exact same thing. So my Sysmon values, be the XML or non-XML. And then I want to see my event IDs number, my event ID 3s, which event ID 3, if you want to look up in here, is an outbound network connection. But I'm sorting it by parent process. So now I'm saying what parent processes are actually making outbound connections. So there's some really interesting aspects. You can see here that I have PowerShell making an outbound connection. That's kind of interesting. You start learning your environment. You're like, oh, that's kind of cool. Well, what's happening here? You can see here that now I have another one, processes that are either adding or subtracting registry keys or making any values. So I have my registry keys that have been recently changed, and I can have a top view or a bottom view of which ones are happening there. And then I can actually see the processes that are actually making those changes. So Google Update is making some changes, probably some Google Update keys. Service spool SV making some changes, and you can start looking at these. Run DLLs making lots of changes. You start looking at those to see for those anomalies, those outliers. But you can do it kind of in a visual format. But so that's kind of some neat things that you can do with Sysmon. Break things out to where they're easily viewable, things of that nature. Processes changing registry keys, processes terminating. So these are the processes that are ending. Unfortunately, my apologies, the connection pipes, they're actually not populating in this last batch of tests, so my apologies for that. But now we're going to move down into PowerShell, and this is kind of interesting. So within the PowerShell command, you can see here that I'm just looking for anything that has a process of PowerShell, so whenever PowerShell is running, and then I want to see the user origin of that. So I'm just going to see all my users that are running PowerShell, and you can see here that I have a system that's running PowerShell. I have my accounts running PowerShell. Then I have the local system running PowerShell. If I had other users, if this was an enterprise environment, you can actually see all the different users that you actually are running PowerShell at a given time. You would expect to find your IT system, your personnel, things of that nature. But if you start seeing somebody that's perhaps maybe in finance, or if you have an executive that is not typically known to use PowerShell often, all of a sudden they start showing up on this list of PowerShell users, that can give you a clue as into something that you might want to take a look at. And then going in here, and Randy hit it pretty good when it comes to encoded commands, hidden commands. What are the commands given by PowerShell specifically? So what I did here is, again, the same thing. You say process is PowerShell, and then I want to see all the commands that are generated from that. So you can see here every command that PowerShell has been running recently. So some very interesting sort of aspects in here. You want to drill down into some of those, you can certainly do that. I also went a little bit step further. I also said parent process. So if the parent process is PowerShell, what commands did it actually run? So these would be systems that PowerShell ran as a parent process. So you can see here already some really interesting things. Who am I? You can see here the app command.exe is looking for passwords. It's looking for tech usernames. I mean, there's already some very suspicious sort of things that are happening in there, and so it allows you a chance to kind of flesh those out a little bit, which I think is very helpful. So then there's encoded commands, the exact same sort of aspect. I'm looking for PowerShell, but I'm doing if log message equals encoded, so either EC or -ENC, which are the little commands for either encoded, or if you want to do the shorthand phrase for PowerShell, it's just EC for encoded command. You look for those sort of aspects.
That's what the cool kids do.
That's what the cool kids do, yeah. So we're just doing some wildcard searching, which is a lot of fun. And this is my favorite one. I like hidden. I think hidden is an interesting aspect, because these are supposed to be hidden from displaying, right? So these are commands that will be run in PowerShell that will not trigger on your desktop, so the user probably won't know about it. Things of those natures. And then I start looking for interesting things like NOP, which is no profile, so it's not using the profile you typically use in your environment. It's also it's hidden. It also has a little bit of a wait time on it, and it's also encoded. To me, that is a very interesting use case. I mean, a very interesting sort of occurrence to have happen. So what I'm going to do here is I'm going to drill down, and I'm just going to go into this particular system. Do a little drill down. You can see here that I have PowerShell coming up. You can see what process ID is coming from. I can start now seeing what host that is coming from. And since this is my test host, I kind of know where to go on it. But I can start seeing interesting things like hash value. So I can see what hash. This should be PowerShell that runs through. But if I click on that little link, it takes me to Virustotal, and I can see, oh, that is indeed a legitimate copy of PowerShell. There's nothing suspicious necessarily about that. So now I'm probably just going to want to look at the command itself. If I look at the command, I can instantly start seeing some interesting aspects. I'm going to just change the screen around a little bit, pull this up, and I see this command in here. So I can see that it's hidden and encoded. But if I wanted to take that command and figure out what was in it, I know that it's base 64 encoded, because that's how PowerShell does an encoded command. So if I take that whole string and I just copy it off, and I'm going to open up a little tab here and just kind of pull this all together. One thing that PowerShell is really interesting with is if you were going to have an encoded command go through PowerShell, really PowerShell has its own way of doing base 64, so you really kind of have to have PowerShell to decode it in order to see it. So what I'm going to do is I'm going to take all this PowerShell command, and I'm just going to copy that, and I'm going to go over here into my little PowerShell window, just paste it right on in there. So there's that aspect. And now I'm just going to run the command to decode that string. And this is an interesting little thing.
I don't have to do that. I can read base 64.
If you can read base 64, then you understand, what it is. But if I do that, I need to enter. I start seeing some very interesting, type of data. You can see that there's capitals and lower cases, and then capitals again. All these kind of like little, sneaky little ways of looking at things. So this itself looks, even without knowing too much about it, I already start knowing that this is kind of suspicious. But there's interesting things in here. I can start seeing that I do have a specific user agent string that is going to be used, so I can start having that to look for interesting things in my environment. I can start seeing,
and we're loading up a DLL too. We're loading up system.management automation utilities. That's weird.
Yeah, so there's like some very interesting things that are already jumping out at us, for these aspects. So I mean, I have more grounds to start doing some. I need to move this little. There we go. So I have more grounds to look at what's happening in this environment. So I'm going to do a little pivot here. Just go 10 minutes front and back of this particular string, and just to see what this user So in my case, it's me. What was I doing on my system? And then I'm also going to do the host impacted, but I'm going to change that to see what is the host origin and impacted. What is the system giving off and accepting before and after this time frame. It's unfortunate that my user account didn't come in here. Oh, my drill down is not working properly, but you can already instantly see that. So I'm gonna have to bail on that example. My apologies. But
you didn't sacrifice to the demo gods, did you?
I did not. I should have
Yeah.
made an effort to do that. So yeah. So there's interesting things that you can get just from seeing the very beginning of what encoded aspects look like. You can start seeing some odd little behaviors just by looking at your commands, which commands are encoded, which commands are being hidden from you as a user. Some very interesting capabilities inside of all that.
All right. Let's see here. So after our AV solution successfully detects and contains some kind of malware, let's not treat that as done. There's actually an opportunity to do some really cool threat hunting there. And this is kind of your baby, Q. You want to talk through this one?
Sure. One thing that I kind of want to say is I think AV is a very interesting log source to pull data from. And it's unfortunate that a lot of people or a lot of organizations have an AV system in their environment, and all they're doing is looking at how many files are being cleaned. They're just looking at a number and they're just comparing that on a month-to-month basis. Or they're just looking at it specifically and says, all right, I had malware cleaned, no more, wash your hands and move on to the next thing. Nothing to see here. And I think that's kind of an injustice. It's unfortunate that that's happening because there's a lot more data that you can get out of your AV systems. Particularly, just the simple question is, your AV is quarantining and removing malware. Well, how did it get there? So it's
That's the big question.
Yeah, exactly. So what happened? Why is it triggering that? And then when we start following that kind of aspect or that trend, you start asking, okay, well, where was that malware cleaned from? And that kind of goes down into the second part where malware is cleaned, but where? Was it put into your users' downloads, or was it in your app data local? Was it in the Windows temp file? Was it in Windows System 32 where it was cleaned from? Each one of those has their own aspect. Essentially anybody that's downloading anything can put anything inside their download folder and have it execute. So you'd kind of expect your AV system to actually remove it from your downloads folder, or even your app data. Your Windows or Chrome or Firefox, they write a lot of stuff to your app data directory. So again, not necessarily suspicious, but when you start thinking about Windows temp file, these start getting to the point where you actually have to have a little bit higher privilege in order to write to that directory, especially Windows System 32. If you ever see an AV system cleaning or quarantining systems or files that are in your Systems 32 folder, that should be highly, highly, highly suspicious, because you have to have admin level rights just to even write to Windows System 32. So you probably have a bigger issue than just malware was cleaned or even malware was put on there. You actually have somebody that has privileges putting malware on that particular system. And that's something that should be, that should stick out like a big red flag that we should go through. So thank you, Eddie. So I wanted to show a little bit of, we use Cylance here in Logarithm, and so there's some interesting log source types that we can go through. You can see here that my Cylance logs, I'm looking at everything that's just quarantined that happened from my environment. You can see here I have threat quarantines. I had a couple catch-all processes going through here, but what I'm really looking at are process paths and then my file hashes, and then the actual file names themselves. What are the actual files that are being quarantined from my system? So like this one, cartoon.exe debug. Well, okay, that's interesting. TCP capture.exe. So there's install engine.exe. Some of these you'd probably expect maybe a little bit, but then there's some other things. If you look at the process path, where are these files being cleaned? I can see here the app data is happening. Okay, well, that's okay. But then I start seeing Kali Linux and then I start seeing Metasploit frameworks, or I start seeing Mimikatz, or I start seeing, DBD, which is a a database file for different binaries that Metasploit uses. So I instantly know that somebody is trying to attempt to put Metasploit on a system in my environment. That, again, even though it is within app data local, but what is the file that is being put down or being cleaned? I see Metasploit was put in there. So now I have a little bit of insight into, who to go talk to, or who really just to go do some more investigations with.
Yeah, and is it making it past some other upstream control that we have been imagining would prevent this,
Right, exactly, 100%. And then, the exact same thing you can take. So if I just kind of filter down on this, I instantly start seeing specific hash values that are a part of that. If I go back to my little Virustotal cheat sheet, look at that. I just already know that there's something more serious in my environment. Now, granted, AV quarantined this and cleaned this for me, which is great on that aspect, but I definitely want to know who that user was. What system or what other things did that user talk to? So I can see it's a Silence, a particular user in here doing that. I can start seeing identity sort of aspects that user might be performing or using. So some interesting use cases to be had in that.
Hey, by the way, a bunch of people asked with your previous dashboard if they can get a copy of it. Is it in the Logarithm community site and stuff like that?
Yes. So it is. We're kind of waiting for our final finish of Sysmon 8 configuration file in order to publish it. It's all built on Sysmon 8, and we have a specific configuration guide going through that. So once that is published, it will be published on the community site, and it'll be a direct link. I'm going to see if I can just push it out through there now, because it really doesn't need version requirements. But if you're using anything earlier than version 7, the dashboard just won't work very effectively. So.
All right, let's move on. Let's talk about lateral movement. I love this one. This is another detection of new combinations, either login attempts or network connections. So login attempts, what we're looking for is a user account successfully or unsuccessfully, either one, logging on to a new computer. This is simple to monitor, but it would be very valuable for detecting when a bad guy has harvested some credentials of some account, and now he's trying to laterally move, extend his horizontal kill chain, and get into other systems with those credentials. And so this is basically a matter of looking at 4624 and 25 from your security log, baselining the tuples of computer name with new account new logon account name and domain fields from those fields. And again, extra credit if you filter out new users and new computers. So what we're saying is this computer's been around for a while. This user has been around for a while. They've never logged on to each other. Suddenly they're trying to. That's worth looking at. We can do the same thing with network connections. And so one of them would be a new endpoint and a new endpoint communicating with each other over TCP. What would we use for this? Either Sysmon event number 3 or the security log event ID 5156, which comes from the firewall. And we're looking for new combinations of source and destination. Now, we want to filter out external IPs because in this case, we're just trying to track this endpoint has been infected by bad guy software. It's under the control of a bad guy, and it's trying, he is trying to reach out and get into other computers from over the network from this beachhead that he's created. And so you're going to, invariably, the bad guy is going to fall outside the normal usage patterns of that system. So therefore, we filter out external IP addresses. And again, we'd want to filter out new computers because they haven't established a pattern of behavior yet. Now, if your IP address that you're dealing with is out of a DHCP range, you want to use your host name. Now, be aware, 5156 from the security log doesn't give you host names at all, DNS host names. Sysmon does if they were used when the network connection was built up, was constructed. So if you don't have DNS host names and the DHCP, the internal address is in a DHCP range, that's going to make it a little more difficult. And I am anticipating people would know why, but maybe I should call it out. And if I'm missing something that makes it hard to explain, then jump in and help me, Q. But the idea is, you know, your workstations are going to be changing IP addresses, and it's not going to be, well, with any kind of DHCP address, it's going to be difficult to establish a pattern of behavior because it's the same IP address but different computers, and so the behavior just isn't going to pan out. So is it all lost? Is it all lost if you don't have the DNS name in your events because you're using 5156 and you use DHCP a lot, then is all lost? Well, no, we can still look for unlikely connection combinations. And so it's the same events, but now we're going to include the direction. So we have event ID 3 or 5156, and we are looking at the direction. And the direction is outbound, and the destination address should never be DHCP unless the source computer, the computer that logged the event, is a systems management server or vulnerability scanner, which in this case we should be filtering them out. Do you see what I'm getting at there? What we are seeing is a computer, we're seeing this computer try to reach out and get into a likely workstation from over the network. That should be really limited because workstations aren't servers. So I'm not a vulnerability scanner. I'm not a systems SMS server. Why, you know, figure out the other systems that might be doing that legitimately and balk at the others. Thoughts on that one?
Again, no, exactly. I mean, it kind of goes back to a point that you made earlier with, like, you know thy environment. You know, if you know what your environment is and what systems are supposed to, you know, or typically communicate, you know, with systems from a DHCP and how they communicate, and then any differentiation, you know, from that, you know, norm that you've already kind of gathered should be, yeah, definitely whitelisted. You should have it, you know, reporting properly.
Yeah. Another possibility is direction inbound. So if the local computer is a workstation, or if the source address is DHCP, so, you know, looking at the computer name in the event log, you may or may not have the ability to determine this is a workstation. But if the source address is within DHCP, and that should be easy to determine in a SIM, because all we need to do is put in our DHCP ranges, right? Then why is a computer trying to get into this workstation from over the network unless the source address, wait a second, am I mixing myself up here? Direction inbound, local computers a workstation, and source address is DHCP. Yeah, then it's suspicious unless the source, yes, the source field in the event, not the source of the event log, is a systems management server or vulnerability scanner. So again, really cool stuff that we can do in order to look for that weird behavior that bad guys are going to do. We're basically setting tripwires around our network on paths that the good guys don't happen to take, but the bad guys wouldn't know not to, you know?
Right, exactly. I mean, yeah, looking for those inbound connections is really key, especially if you have a dynamic environment that changes IPs regularly. You know, why would that external system know which system to communicate with, you know, unless it's a target?
Yeah. Persistence. So if we, through a drive-by download or through a buffer overflow in a Word document or a macro in a Word document, a buffer overflow in a JPEG image, whatever, we succeed in getting a little fragment of bad guy code to execute on some end user's computer, or admin for that matter. One of the first things we need to do is establish persistence so that when this system reboots or the user logs off or the program terminates the process, we come back. And so the bad guys have developed all kinds of ways to do this. I've devoted an entire webinar recently to that first row of gaining persistence through registry keys. And basically what I did there is I went out and got the auto runs utility from sysinternals, and I pulled out from it all of the registry keys and made a list of that. What I would like to do is monitor for registry changes to those keys, figure out what is normal for my environment in terms of which keys, which actors, both, and by actor that could be the process name and or username, and then start watching when I see new things pop up. But the registry keys are, go ahead.
Yeah, within the dashboard that I showed earlier, I mean, if you can, this is specifically for Sysmon, but I mean, if you had, specific EDR solutions that also do registry key monitoring, things of that nature, then yeah, most certainly looking for those users or those processes that specifically make those changes. Sysmon has a really good way of doing that, and I showed you, how to kind of narrow down and make the special filter on that. But it's really key, and then using that to you can either build whitelists off it, or you can actually just use your own intuitive visual sense if that's how you work. Just makes it easier.
Yeah, absolutely. Now, hey folks, there's a lot of registry keys, okay, and there's a lot of legitimate use of these auto-run registry keys. So this is an undertaking. But how about this? Are you running any of your workstations in least privilege mode, meaning that the user of the workstation does not have admin authority to their workstation? If so, you have just obviated the lion's share of those registry keys and reduced your monitoring burden to make it more worthwhile to monitor those keys, but also you have forced the bad guy into some of these other areas. So it's really valuable to know if your users have admin authority to their workstations or not. It can impact the monitoring that you do, because most of these registry keys, I guess that's the point I failed to make, most of these registry keys require you to be an admin. And yes, before someone else says it, if you're an admin, then all bets are off. But it doesn't mean we shouldn't try to catch bad guys that have already gotten admin authority. Let's see here. Scheduled tasks. Windows Security Log gives you very nice events for any kind of change to scheduled tasks. A new and very weird and indirect and stealthy way of getting persistence is with something called WMI eventing, and I've done a webinar on that. You can catch it by monitoring Sysmon events 19 through 21. And then services. Hey, some bad guys just simply add a service to run in the background, and you'll catch that with 4697. This is not an exhaustive list of persistence. Just we don't have time to go through every possibility, but this would get you started for sure.
Yeah, these are the biggies, the ones that are used very regularly. Yeah.
Yeah. DNS abuse. Now, the bad guys use DNS lots of different ways. It is one of the few protocols that we allow to go out on the internet. So one of the first things you can do is simply look for people that are using the DNS protocol as a command and control or even data exfiltration protocol. And one way that the bad guys do that is by instead of initiating HTTP connections outbound, they just use DNS. And so instead of there being a DNS server at the other end on that destination address, there's a bad guy command and control server. So how would that show up? Well, one possible way is the bad guy sends DNS queries directly, whereas your normal client on your network is going to be going to the DNS server that you've configured it to use. And then that DNS server, if it can't answer the question from cache or local zone files, will then send it out over the network. So just have your firewall tell you whenever somebody tries to outbound on DNS. You say, well, we have that blocked. Well, you still should monitor for it, right, Q? Because good, you blocked it. But if we do see somebody outbounding on DNS, then that's very indicative of bad guy software, and we can follow up on that. Kind of like it's the same token as AV. Oh, how did this AV get on the system? It got on the system in a way that it shouldn't, from Outlook. But I thought we blocked EXEs and stuff on Outlook, right? So, follow up on this stuff, even if it is successfully blocked. You can also track abnormally large DNS packets. That'll require you to baseline what your normal range of DNS packet size is. You could also monitor for changes to the etc host file on endpoints. This can be indicative of things similar to DNS poisoning, not exactly DNS poisoning, but the bad guys sometimes will hard code values in etc host to trick your computer into going to some other system than the one it thinks it's going to. And then rebinding. You want to talk about rebinding? At the same time, I'm going to make you the presenter.
Okay, excellent. So rebinding is a very interesting case that I've just kind of recently come across, which is essentially it is a using your browser as kind of as a victim proxy, essentially. So what happens is, let's say you as a user are just kind of surfing around and you visit a website that's either been waterholed or it has a malicious ad or something into it. So what happens is that ad, when your system connects to it, it loads the data from that ad, and that ad may be infected with some malicious JavaScript or something like that. And what that malicious JavaScript essentially does, it's very simple. It just makes your browser redirect to it simply does a call to an address. Usually it's its own address, the address of the ad that you're searching towards, and then it is followed with a API query or something of that nature. So REST API allows a browser to actually go to a specific site and then initiate commands to and from that site. So what this ad does is it forces you to make a repeating REST API command over and over and over and over again. And then what happens is the TTL of that victim or of the malicious ad is actually set really, really short. So what happens when your browser tries to refresh that connection, the malicious ad actually sends an internal IP address to your environment. Now your browser, which is now just a victim of it, takes that new IP address as, oh, okay, I'll just take this command and send it to this new host. And it happens to be an internal system. And then it sends those API requests to an internal host that, perhaps was not accessible via an external environment. Now the actor has been able to send malicious code via your system, rebinding its DNS query name to an internal system, and now you have commands that are being run. So that's kind of the premise. That's the scope we're running from. So how would we look at that type of information within a SIM? So within a SIM, you're essentially looking for anything that URL is not blank. So you're just kind of using a very large sort of set. So you're just trying to find all the different URLs that are happening in your environment. And then you can kind of do some little Lucene foo with them, and you can start looking for interesting things that may be happening. Or in this case, we're specifically going to be targeting that API, that REST API sort of connection. And what are things that are typically used within a REST API? File type. So typically, if you're going to pull an API list down, you might pull a file type being JSON or a file type being XML or something of that nature to see what kind of file type you're pulling down. This doesn't look anything. It's just a Chrome component. just using a file type PS host. So there's nothing really there that's interesting. Other things that you might want to look for are like, say, usernames or passwords or something of that nature. So if I just type in user, I can see, oh, there's a third-party beacon. Doesn't really look very API sort of specific. But what else can I find? Method is typically what is the method in which these logs are coming in. The same log got triggered on that one. A couple others. Again, these don't look very API specific. But okay, so I'm not really finding anything specific, but how about if I look for JavaScript specifically? So I'm going to do .js, and oh wow, there's actually quite a few JS sort of files on it. But we know that the JavaScript is actually being posted to your environment instead of like Git. So let's just kind of filter down upon the post. Just double click on that, and all right, look at this. I can actually see that I have some JavaScript that is being loaded, with some specific, files going through this. Now, this particular example doesn't actually have any malicious rebinding that was successful through it. It's just showing you that JavaScript is being loaded and how you would use logarithm in order to identify that sort of aspect. But using logarithm, using the web UI to look for usernames, to look for different aspects of API sort of commands, and then saying, okay, if I do find an API command, then looking at the directionality of that. Right now I can see that everything is internal, but if I see some directionality of API commands that are now going internal into my environment, I might want to start doing a little bit more of an investigation back and forth on, is it the same system and the exact same command going from an external site now being switched to an internal site? If so, then that would be subject of a DNS rebinding aspect. So just kind of an interesting use case, an interesting way to taking what you would consider to be a threat hunt environment, and then how would you model that within your SIM environment?
Yeah, it's very cool. All right, so let's finish up with a few more threat hunts here. And this is really the last one, but it could take so many different shapes and forms. We should probably maybe do a whole webinar on this, but it's basically bait the bad guy. And before anybody gets the impression that I'm a big hunter, I'm not, but I'm just aware, probably like a lot of you, that one way that they hunt is they bait and get the prey to come in, right? Why aren't we doing this more with our bad guys? A lot of security companies are running honey nets, and there are virtual honey nets that you can download and run, and they have varying levels of sophistication. They don't necessarily use a lot of resources, but it can be a very cool thing to do. What would you say, Q? A lot of organizations, maybe most organizations, are only using a fraction of their IP address space. Would you say that's true?
Oh, yeah, for sure, especially when you start doing private IP stuff. Yeah, most certainly.
Yeah, exactly. So you're using the whole 10 block. Why not take large swaths of that block and run a honey net on there with something that answers back if somebody pings it or tries to connect on various ports, and as soon as that happens, alert on it. Find out where is that coming from. What are the legitimate sources of that, Q? Your vulnerability scanner,
Yeah.
which you could easily configure not to hit those ranges. Go ahead.
Yeah, no, exactly. Before I want to venture too far into this, and it kind of has to be the caveat that's kind of said from the very beginning, if you're using honey nets and honey pots, things of that nature, there is an aspect of a legalese sort of, protecting yourself from that sort of from a honey pot being maliciously compromised and then you not catching it. You could actually be held liable for allowing attacks to happen, not against you, but to other actors. If something happens on a honeypot and then you don't block or stop it, and then it's allowed to continue. So to mitigate that sort of aspect, make very good due diligence that you are monitoring your honeypot, that you are keeping your honeypots relatively up to date so they're not completely vulnerable to everything under the sun and drive-by things happen. It does take a lot of maintenance and effort in order to maintain and hold a honeypot. And then you have to do a lot of monitoring of that system. You have to treat it as a real system, and that can be an overhead, and especially an administrative overhead, especially for a security team, because IT teams don't really want to monitor it so much, so it's more of a security sort of aspect to go through that. But I just wanted to say that caveat real fast. There is a legal aspect.
And that is true, but I think it's more of an issue if you're running a true functional honeypot. There's a lot of fake honeynet systems out there where there's nothing really there. It's just something that is listening. It's bound to 10,000 IP addresses, and it's going to answer back. But if the bad guy's going to quickly figure out that is not a true system, right? But we don't care.
Yeah, there's honeypots. There's one called Kippo, which is very common, and all it is it opens the port essentially. All it does is gives the illusion of a system without ever there being a system behind it. So definitely trigger and flag on those things.
Okay, but now this also, your comments also take us some other directions here of what, instead of standing up entire networks or systems, why not a honey share or some honey files, which you could put anywhere. File shares are just one place where data is nowadays. Why don't we put some honey files up in SharePoint, in Dropbox or Box.com, and all these other places? And it takes a little bit of imagination and thinking about how do we put it somewhere where legitimate users aren't going to be opening it up and triggering it too much. I mean, we can live with some, right? There's also, some organizations train their users, but we use an out of band way of notifying users. If you see a file that begins with this, or if you see a folder named this, just stay out of it. And that's all we tell them. And it's out of band. We do it in a meeting verbally. So that somebody who's reading, if there's a business email compromise, they won't see this. We don't post it on the intranet for everybody to read.
No, most certainly. And the cool thing about honey things, and don't get me wrong with my previous thing. It's just something that has to be said. But
sure,
honey things, so the honey items are so much fun to work with from a security perspective, because any access to them at all is not supposed to be legitimate. I mean, you put them there specifically as red herrings. So if anything happens to them at all, you instantly know that that's not supposed to happen, because no one has any legitimate reason to be messing with these at all, because I put them there. So that aspect, if you're monitoring, with the honey systems, and you're monitoring what happens to them, honey shares, if anybody connects to that share, they're obviously looking for something, and then you can use that as investigation points. It's so much fun to play with, but because it's so not false positive. It's so close to like true positive results.
High signal to noise ratio.
Exactly. How often do we get to say that in a security environment? We don't get to say that very often, so it's fun.
Hey, why don't you talk about well, save it. Let me talk about honey accounts.
Okay.
So this is really awesome. Create some bogus user accounts out there that are named, administrator or sysadmin, or, come up with other names that maybe aren't as obvious but would still be very attractive. And just look for logon attempts to those accounts. Good. Do the same thing with some basic usernames too, because maybe these guys are trying to be very stealthy. So just create some absolutely innocent looking, credible user accounts out there, and make sure they don't have access to anything, and then monitor for successful or failed logon attempts to those accounts. Again, it's the same thing. It's a honey object. There's high signal to noise ratio. But this one I want you to talk about, because it comes from you, Hugh.
Sure.
Active documents. This is very cool.
Sure. So active documents, you can consider them bugged documents. You put inside of, let's take a Word document, for example. You have an XLSX, or you have a docx file or something of that nature. And when it is opened, it has like a little image file that's embedded in it, and an image file essentially does a ping back to the origin host and where it's coming from. So what happens is you can embed a document that's say social security numbers, or employee records, or something that looks very enticing, to be grabbed. And once that file is grabbed and then opened somewhere, it does a phone home, it does a ping, and then So what happens from that is you can set up a list that say, anytime I have an incoming connection to this IP address, you can set up that as a specific IP address that is either hosted out in the cloud, so it's like an AWS account, so it looks a little bit more legitimate in case the bad guys are looking at it. It's not coming directly back to you, say, just going out there to AWS or DigitalOcean or something of that nature. Then when it's going to that, you know that anything that connects that's not necessarily you connected to that system should be monitored. And then you know if documents are opened, and if that document is opened, from where is it being documented, because you have that origin IP address. It's just the concept of it is just so much fun. You're really counting on the bad guy to fail in their own OPSEC or fail in their own way of opening files securely and discreetly. It's kind of cool.
So Arturus is saying we can't do that legally. It's something. All the stuff you got to look in, and we're not lawyers here, so you've got to check with your legal folks to see if you can do it. But I mean, you sure as heck can send somebody a Word document that goes out and asks for a web page. So I don't know if it comes down to intent or what, but at any rate, just thought I'd throw that out there in this litigious world. That's kind of a standard disclaimer with everything, right? Let's see here. Here, I'm going to share your comment out, Arturus, so people can see. He's mentioning a couple of people that had an extensive talk on that. Let me say thanks. So, folks, if you're interested for that, just look in the question window. All right, so Q, you got one more demo for us.
Yes. This one is kind of interesting. So this one goes into the honeypots. And honeypots, essentially, I'm just going to go right on over here. Where did it go? There it is. Oh, it closed. No. Give me 1 second. There it is. So really what honeypots are, this is the old thick client, so if any logarithm client, people are happy with this. The thick client is where you can make lists and use lists. So essentially what honeypot systems are just lists of things. And then what you do is you make AIE rules that are triggers of when those lists of things are hit. So what we have here is I have honey tokens, just specific documents or specific items that will be triggered when they're hit. If I have specific IP addresses that I'm specifically looking for, I'll make lists of those. This is your host systems. These are the systems that are your actual honeypots inside of your environment themselves. Your log source types, if you have specific honeypot systems, like say Kippo, which I mentioned earlier, WordPot, which is what I was talking about, the active document system, PHP MyAdmin, anytime that you have PHP requests that could be used as a honeypot sort of aspect, you're essentially just looking listing out all those things that are considered honeypots. So this is where you put hashes, all that stuff that you know is fake and that you just want to monitor to see what happens to it. Then inside of your AIE rules, you're just making AIE rules. This one is looking for hosts. So basically, if a host origin or impacted is part of your honeypot host list, send me an alarm. Send me an alert. Let me know when that happens. And that is the extent of how to monitor it within a SIM. So what I'm going to do is I'm going to look in here, and this is kind of what it looks like when you have a trigger on that. You can see what system hit that. You can see where it came from. You can see your honey. You have specific processes that have ran on those particular systems. Like this one, LSAS ran on a honeypot system. Probably, again, not necessarily legitimate. Why would a honeypot need to use LSAS? Again, you get to choose those, and you get to say, this is how I want to monitor it. This is the activity that I want to see. This is where I want to know it's coming from, or where they're going to, or what they're targeting. All of this is nothing. Every single one of these would be not supposed to happen. So it's pretty high signal to noise ratio.
Well, cool. What I was saying, Q, is for folks on the call that aren't logarithm users in case they're like, wow, I didn't know logarithm could do that, or I wish I could do that with my sim. Like, what's the best way to engage? Is there online demos or what?
So the best way to engage with Logarithm to look more at this is, obviously I'm always available for questions and comments, things of that nature. If you have a customer relations manager, you are a client of Logarithm right now, communicate with your customer relations manager. They can put you in contact with professional services, with myself, with specific administrator groups. If you want to have, if you are part of Admin Copilot or something of that nature, there's a lot of programs that we have in Logarithm to kind of help users get into a specific direction of what they're asking for. So that'd be my first bet. There's also Logarithm community, posting questions on community of specific aspects. They always get funneled to the right spot. It's a good spot to go. We have some active users that are always monitoring that for specific questions. So those would be my specific choices.
And that's if they're a Logarithm customer. I was even saying, maybe they're like, whoa, I like Logarithm, I'd like to learn more about it. So sure,
yeah, if that's the case, then most certainly we'll go to sales@logarithm.com. We can get that. We can start having you can have POCs, deployed in your environment. They can specifically look at some of these aspects. They're really good. Our sales engineers are really good at use case, POC, proving the concept, and especially when it comes to threat hunting. It's a big topic. We write a lot of papers. If you just do Logarithm, if you look up in the in the Google, if you look up Logarithm and threat hunting, we do have some guidelines and guideposts that are publicly available. Logarithm has blogs that are available, put you in the right direction. There's lots of avenues to get POCs developed in your own environment as well.
Well, folks, thanks for spending time with us today. Hope this was valuable to you. I mean, as you can tell, I love threat hunting, and so does Q. And there are really some feasible things that you can do, even if you've got limited time and resources. Don't be afraid to do threat monitoring and, threat monitoring. I keep trying to say threat hunting and monitoring of certain scenarios, even if you're aware that there's possible ways around them. Just be aware that, okay, I'm not covering every base, and it's impossible to cover every base. But, I guess my bottom line is, don't be a security cynic. But you had a couple other good points. It's really important to have confidence in your logging pipeline and your monitoring. If you want to expand on that, you can, Q, before we close. The only other thing I'd say is that you really want a good ability to do ad hoc querying in order to test the feasibility and also to refine your concept. Because with a lot of these threat hunts, I called out things that you may need to baseline or get to know specific to your environment. And so you need that ad hoc querying capability. The other thing, Q, that I would see a lot of folks doing is starting out manually threat hunting some of these scenarios, but then as they refine their process, automating more and more of it with security automation and orchestration.
Most certainly. So kind of the process, there is a process for going about threat hunting. Just from the very beginning, just to hit back on the pipeline confidence, it's a data science sort of term, but clean data in, clean data out. So making sure that you have the data that you're looking for to begin with will make the process so much easier. But going through, and then how do you visualize that data once it's gone through? I think I'm obviously biased, but Logarithm has, the web UI is really nice to be able to do investigations and searches and pivot through things, which is very helpful. But the process for threat hunting, I mean, it is never really an ending cycle. I mean, you go through a loop where you do have to do a learn phase. You kind of have to know what it is that you're targeting. So that goes through with you doing research in the environment. What are my peers actually being targeted with? do I see that in my own environment? If, well, I don't know how to look for it. Maybe I have to do some research to figure out what that attack actually looks like. And so what you do is you're building your toolkit for what are the pieces that you're going to be looking for? What are the indicators of compromise that I might be seeing? A lot of things like things of that nature. The DNS rebinding was something that I just kind of heard through a dark reading site, and then I went through Wired, and it's like, oh, this is actually pretty interesting. I'm going to do some more research on it, and then just kind of, oh, this is how that technique works. So then it was just, well, how would I detect that? I mean, I have URLs, URLs that are in my environment, so let me look at those and see if I can see directionality on them. And it just kind of starts going from there. Once you get to that point where you actually have your research, and then you have your hypothesis of what it is that you're looking for, and then you do your test on seeing if that is actually true or not, once you either prove or disprove that thing is working, now you have something to turn into an automatic process. You can make an AIE rule out of it. You can start implementing SOAR and security orchestration and automation out of it, and you can start using smart responses or swim lane or Domesto or Phantom, to build templates and guides to, it no longer becomes so much of a threat hunt, but more of just a part of your normal security operation process. So threat hunting should really be looked at as that first initial investigation, and then once you either prove or disprove that it's happening, then you turn it into standard security practice and monitoring capabilities via your solutions that you have doing that. So threat hunting it's a fascinating field to me. I really enjoy it. And just because you can actually, you do the testing, you do the research, and then you do the testing, and you come up with your results, and I enjoy that process.
Likewise. Well, folks, that's it for today. Keep catching those bad guys, and we'll be in touch again soon. Bye-bye for now.